graders, and welcome back. This is your video 4.3.1, How Many Degrees? So you have been working on your workbook page 209 on taking smaller polygons and fitting them together to form a right angle or a 90-degree angle. And we're going to take a peek at some of the things that maybe you did and look at how that we can make that into an equation for adding up our angles. Okay, so some of you may have decided to take two of your E polygons and put them right here in one of the corners. We're going to use this one right here. And we notice that when we put two of our E's together, that it forms a 90-degree or a right angle. Now, if I know that I want to get to 90 degrees, and I notice that I've used two smaller polygons that are the exact same shape, same size, what can we go ahead and know that each of these angles measures? What do we already know that each of these angles measures to be? They're the same shape and they're the same size. Well, you could say 90 divided by 2, and then you would know that this angle and this angle measures 45 degrees. And so we know that we have two polygons that are the same size, same shape. So we know that 45 degrees plus 45 degree angle equals a 90-degree angle or a right angle. Now you're going to notice this little small O that I've put right here, and that symbol stands for degrees. And you've probably heard that word when we were talking about temperature, but it also is the term that we use for the measurement of angles. So we say 90 degrees is equal to 45 degrees plus 45 degrees. Okay? Let's look at another example. Maybe you used these little guys right here, some O's, just like we saw in our last session. And maybe you decided to put them, let's put them right here. There we go. So we have that one, and this one. So again, we have three of the exact same shape, three of the exact same size, and we know that when we put all three of these together, they equal 90 degrees. So what does that already tell us? That these three angles must equal. What is the measurement of each of these three angles? Well, again, they're the same size, they're the same shape. We know that they're going to equal a right angle or a 90-degree angle. Would I be adding three different numbers? Or would I add three of the same numbers? Think about it. Same size, same shape. We're going to be adding three of the exact same numbers. So what three numbers could I add together that would give me 90 and would be the measurement of each of these angles? If you said 30, nice job, 30 degrees. So 30 degrees plus 30 degrees plus 30 degrees equals 90 degrees, which is a right angle or a 90-degree angle. Okay? I want us to take a peek right here at our power polygon E and our power polygon F. Now we noticed from the last video that we were able to use F to measure into our big square here. We were able to use two of those to give us 90 degrees. And we just noticed that we were able to use two of our e's as well to give us 90 degrees. And we know that when we're using two of the same size and the same shape, it must be 45 degrees. Okay? But E and F look completely different. They're the same shape. They're triangles. But look at how much bigger E is in comparison to F. E is much bigger. So, measuring angles is really different than measuring length or area. And thinking about these ideas as we measure other kinds of angles, we want to keep that in our brain as we measure over the next few sessions. But my question is, how is it if these are two of the different shapes, how can they be measured the exact same thing of 45 degrees? You might say that if you can look at the beginning of each of these angles, right here and right here, they're the same width apart. Look at that. Look at how that fits perfectly right there. And then you could look at how you could fit that right there. Fits perfectly right here in the corner. So even though one's bigger than the other, they have the measurement of the exact same angle of 45 degrees. All right, that's it for now. I'll see you soon, fourth graders.